In this video, we are going to be solving the AP problem from 2012. We're going to be doing problem number 4. This is a 2D array problem. So I have my text editor ready to go to type up my solution. I also have the problem pulled up on a browser. If you just Google APCSA 2012 FRQ, you should be able to find this PDF, and you can scroll down to question 4, which is this question that has to do with grayscale images. So I'm going to go over the problem in this video, and you should follow along, and hopefully you understand how all the 2D arrays are working, how all the rows and columns are doing their thing. So let's read this description together. It says a grayscale image is represented by a 2D rectangular array of pixels. Great. And a pixel is just some value. This is a gray image. So it's some value from 0 to 255, representing kind of the shade or the intensity of that pixel. It says here black is 0 and white is 255. And if we look down here, here's a class we've never seen before called gray image. They do give us 2 constants representing black and white. We are welcome to use those, but you can also just use the values if you want to. The thing that's really important in this class is I have one private instance variable, it's shown here, called pixel values. And what type is pixel values? It's actually a 2D array of ints. So there's our 2D array. It looks like we're going to be writing 2 methods in this problem, one called count white pixels and one called process image. So let's look at count white pixels. Here's the description. We're going to write the method count white pixels, which returns the number of pixels that contain the value white. And remember, white is actually 255. That's what it says up here. So for example, let's say this is pixel values. How many 255s do you see? Is 1, 2, 3, 4, 5. So this should return 5. Great. Let's go ahead and write this method, public int count white pixels. So this feels very similar to actually 2 videos ago. We did that little example where we were counting up all of the number 3s in our 2D array. This one's almost exactly the same, except I'm counting up the number of 255s. So to do that, I need to start by declaring a counter. So let's say int counter equals 0. Don't I RC cola through my 2D array? For sure, I totally do. So let's do for int r equals 0. R is less than, what was the name of my 2D array? If you forgot, let's go back over here and scroll up to the class. Oh, look, there it is. It's my private instance variable called pixel values. So pixel values dot length is the number of rows, r plus plus. And for int c equals 0, c is less than, what do I put here? I put pixel values bracket 0 dot length, c plus plus. And in here, what do I want to do? I want to check that this particular value, this pixel, has a value of 255. So I'm going to need an if statement. If pixel values bracket r bracket c equals 255, or if I wanted to, I could do white here, because that's a constant they gave me. Either way, then I'm going to counter plus plus. And what do I always have to remember to do whenever I'm writing a method that returns something? I need to return something. Let's return counter. All right, that was part A. Hopefully felt fairly straightforward. This was a pretty nice part A of a question. Let's take a look at part B. So part B is here to write the method process image. This modifies the image by changing the values in pixel values according to some description they're going to give us. The pixels in the image are processed one at a time in row major order. We've never actually heard those words before, or you might have, but I don't think I've talked about them before. Row major order. All that means is that when I process the 2D array, I go row by row, like I'm reading a book. Now, this is the way that our RC Cola for loop actually works. So this is just saying, do your regular RC Cola for loop. We're going to do it in that order, right? That whole row, that whole row, that whole row, and then that whole row. The pixel at position row call is decreased by the value at position row plus 2, col plus 2 if that position exists. If you try to subtract and you end up with a value less than black, which is 0, if I end up with a negative value, the pixel is assigned the value of black, or 0. The values of the pixels for which there's no position, row plus 2, col plus 2, don't actually change, which means that if I'm looking at this pixel, there's not a corresponding pixel 2 rows down and 2 columns over, so this one stays the same. And it gives me this little example, so let's walk through and make sure we understand that. 221, I can go 2 down and 2 over, that's 0. 221 minus 0 is still 221, so it's 221 in the result. 184 minus 0 is 184. Finally, something starts to get interesting. 178 minus 78 is 100. There we go. This one doesn't have 2 down and 2 over. Neither does this one. We can go here. 84 minus 255. That would give me a negative number, so this one actually sets it to 0. 255 minus 130 is 125. 255 minus 84 is 171. You can actually see the rest of these all don't have 1, 2 down, and 2 over, right? These last 2 rows are a problem because of the row, and these 2 columns are a problem because of the column. Great. So it looks like, am I going to need an RC Cola for loop? For sure I am. Let's go ahead and write this method. So this is going to be public void process image. And just to remind you, what does the return type of void actually mean? It means I'm not going to return anything in this. So I'm never going to write the word return. All I need to do is change the private instance variable pixel values. So I don't need to do anything before my RC Cola here. I don't need to create a variable or anything like that. Let's do this. For int r equals 0, r is less than pixel values dot length, r plus plus, and for int c equals 0, c is less than pixel values bracket 0 dot length, c plus plus. We need to subtract the pixel at r plus 2, c plus 2 from the one at rc. So how am I going to do this? Let's do pixel values bracket r bracket c minus equals pixel values bracket r plus 2 bracket c plus 2. So again, whatever value is 2 rows down and 2 columns over, my original value loses that many. Now, we have one thing to think about here, which is, isn't it a problem? They said it was a problem if this goes below 0 or below black. I need to set it back to that value. So let's do this. If pixel values RC is less than 0, then don't I actually just want to set this to 0? So I can do pixel values RC equals 0. Now there's one other thing I have to be nervous about. Remember, whenever we're looping through a one-dimensional array and I'm like checking my neighbor, so I have or let's say it was nums bracket I plus 1, I actually had to stop my for loop 1 early. And that's because if I'm looping through an array and checking kind of the one after me, you know which one doesn't have something after it is the very last one. So I always needed to end my for loop 1 early. In this case, I'm checking 2 rows after me, which means when do I need to end my row for loop is too early. So I'm going to need a -2 here. -2. And to look at the columns, I'm actually checking 2 columns after me, which means that I need to end the column for loop too early. So this works exactly the same way that we got used to with arrays. If I'm checking 2 rows beyond the value that I'm on right now in my for loop, that means I need to end too early. And if I'm checking 57 columns after where I am in the for loop, then I need to end 57 early, right? If you see a plus here, then that minus needs to happen up here. Same thing here. Works the same way. Let's say I was trying to check the 1, 2 before me, right? So this was r minus 2. Then I can't start my for loop at 0. The very first row I can look at is actually row 2. So I would need to change the start to a 2. And it will work the same way with the columns. So there we go. This was our first AP problem with 2D arrays. It's one of the more straightforward 2D array AP problems that has been given over the past few years. Hopefully this didn't feel too bad and felt not all that much harder than some of the examples that we've done in class.